So what is long column? There are some certain parameters. Let's look at the parameters first. Here L is the effective length of the column. D is the lateral dimension of the column. Okay. And K is the minimum radius of gyration. Minimum radius of gyration. So if L is divided by minimum radius of gyration greater than 50, if LE divided by K means greater than 50, or effective length divided by diameter, this lateral dimension of the column, that is LE divided by D, which you will find in textbook. If it is 15, then the column is termed as long column. Okay. So what is short column? When length of the column is less. Mind it, length of the column is less here. Compared to its cross-sectional dimension, it is called short column. So short column, for this case, LE divided by K minimum less than 50, or LE divided by lateral dimension less than 15. Okay, you have to remember these two terms, these two conditions designating a column as long column or short column. Here you can find the crushing load. The load at which short column fails by crushing is called crushing load. Now, what is buckling load? As we discussed earlier, that is buckling load in terms of column when it is showing some amount of deformation, which is actually, we know this term as bending. It is called as buckling in terms in case of column. Long column, which are also called cylinder column, when subjected to compression, deflects or bends in lateral direction. Okay, the lateral deflection of the column is called buckling. So this phenomenon is called buckling. Okay, buckling of column depends upon following factors. Kitna load are, how much load is coming, length of the column. If the length of the column is higher, then the tendency of buckling will increase. End condition of the column. End condition means if column is restrained by fixed support or attached to the hinge support. This is the end condition. We will discuss it later in other next slide. Cross-sectional dimension of the column and material of the column. Now here you can see the end condition. If a column have if a column have two pin joint, here we are showing pin joint as like this. Okay, and fixed joint will show it as like this. So for this case, there are effective length given for hinge, that is 1 for one end hinge and other end fixed, that is 1 by root 2. So both end are fixed, then 1 by 2. If one end is fixed and other end is free, then LE is equal to 2N. We have to remember this value for evaluating the numerical problem. Next, here is the value of least lateral dimension, sorry, least radius of gyration. Actually, this term, minimum radius of gyration, we can find it for these cases. As we see, the effective length is varying for different end condition column, and we have to remember this minimum radius of gyration or radius of gyration value. It will help us later. Now, a very important in terms of column, Euler's formula. When it was introduced, historical background, if we look into the historical background, then we will find in 1757, Swiss mathematician Leonhard Euler, the column will remain straight for load less than the critical loads. The critical load is the greatest load that will not cause lateral deflection, that is called buckling. For loads greater than the critical load, the column will deflect laterally. Okay, next, here are some assumptions behind the Euler's theory or Euler's formula. That is, column must be homogeneous, load must be axial only, free from initial stress column, weight will be neglected, initially straight column should be initially straight, no eccentricity of axial load, pin jointed or frictionless means there will be moment. Moments are not restricted there. Fixed end are rigid. So rotational deflection will be there. Cross section of the column is uniform throughout its length. Direct stress of this column is very small as compared to the bending stress. What do we mean by this terms? The material is compressed only within elastic range of strains. Okay, within elastic range of strains. The length of the column is very large as compared to the cross-sectional dimension of the column. The columns fails only by buckling. There are the assumptions of Euler's formula. And this is the famous Euler's formula, which is, if I dictate it right, then it is P subscript CR is equal to pi square EI divided by KL whole square. And what are the importance of these terms? Here, PCR is the critical load. We will introduce about the crippling load later, but mind it, PCR is the critical buckling load Newton. Here, as you know, is the modulus of elasticity in Pascal. I is the point of inertia of the cross section, and L is the length of the column. K is the effective length, depend upon the end condition. So this equation is the Euler's formula for column. That is PCR is equal to pi square E I divided by K L A. Next, there are some limitation in Euler's formula. Okay, so in pictorial representation you can find why we are if we summarize this thing, then it will be look like this. Yes, sigma R is the crippling stress. Crippling stress means crippling stress is the stress at failure. When column is facing the failure, then the amount of stress experiencing the column at that time is the crippling stress. And in very numerical problems, you are about to ask what is the amount of crippling load experiencing during the given loading condition. The terms L divided by K is called as slenderness ratio. That is effective length upon radius of gyration. Okay. So we have to remember about the critical stress or crippling stress from this limitation. Now, actual limitation is it is applicable to an ideal strut only in practice. There is always proofness in column and load applied may not be exactly coaxial. Okay, it takes no account of direct stress. It means that it may give a buckling load for struts far in excess of load which they can be withstand under direct compression. Okay, so thank you. This is the end of the session. We will discuss some important numericals related to the column in next class. Thank you for listening. Thank you for your attention. We will see you next